Welcome, ladies and gentlemen, to the Vector Forum this year and to my presentation about semi-formal requirements engineering at ZF, which we titled Intuition Beats Complexity, because we believe that we can get the attention of people and we can get really good requirements only if we make it really easy for people to write and understand the requirements. My name is Joachim. I'm working at ZF in Koblenz as Chief Engineer for Software Systems Engineering and have a lot to do with software requirements and software architecture, but also many other topics for the braking system development, where we develop stability control systems, electronic park brakes, and various other braking systems. What makes requirements engineering hard today? We have found at ZF that there are several problems that we frequently meet over and over when people write or people read requirements. One thing is, it is typically not very intuitive to write requirements or to read requirements, because requirements follow a certain formalism. We often require people to write in a certain template language, which is maybe not the natural language they're using typically, and actually enforcing this template language onto people who want to write requirements is typically hard, because they come from using natural language day by day. They want to write requirements as they speak, and if you want to press them into a template language, they will typically not like it in many cases and would rather like to use a more expressive language. Also, if we want to write requirements a little bit in a more formal way, for example, using template languages, unfortunately, author has typically no immediate feedback from the tool whether the language that he is using is actually correct, whether he is using the right template or using the right words. The requirements engineering tools typically don't give you that feedback. So if you're not trained day by day in writing the requirements and only do it from time to time, you typically need a lot of corrections and iterations by reviewers or whatever to use the right language. So therefore, today's approach in writing requirements, at least as we see it, is not very scalable to many locations, many developers whose day-by-day job it is not to write requirements, but to do something else. It's also typically very difficult to find the right abstraction level in writing requirements. Some developers tend to write requirements in a very, very detailed way, which makes it harder for people who are not so much in the detail to understand what they mean. Or, on the other hand, requirements could be written on such an abstract level that people can't develop it or people can't test it. So finding the right abstraction level is something that people always struggle with. Since we are writing for automotive and since we're writing for safety, we usually have standards and norms who ask for a lot of formalism, such that we write good requirements. That might, however, lead to people writing something like pseudocode, which is, again, not really readable and maybe also too much detail involved in requirements writing. But if you don't do that, you typically would have no formal proof of the requirements completeness, consistency, and other important aspects. So we are typically struggling between the need for a very high formalism to fulfill the standards, and on the other hand, the need for a very simple usage, especially if we want to scale the task of requirements engineering to many, many people whose day job it is typically not only to write requirements. So what we try to ask here and what we try to answer today is the question, can we write requirements such that they're easy to read on the surface, nevertheless provide enough information in the background, they allow you for a drill down to give you actually deeper information, and that are still sufficiently formal such that you can automatically analyze them for correctness and consistency, for example. And To overcome that problem, we at ZF Braking System have introduced for our software requirements a specific language which we somehow borrowed from social media approaches, and we call the language hash trace. So the language is actually very simple. It uses hashtags which are embedded in natural language. For example, we say when the vehicle speed, and vehicle speed is a hashtag here, exceeds the speed limit recognized by a traffic sign recognition and so on, then the system shall play an alarm sound. And you see that several hashtags are used in that requirement. So that's kind of borrowed from social media, from Twitter, but the language is a bit more formal than what you could see on social media. Especially all hashtags that we are using here need to be declared. So they follow a quite simple notation which declares the hashtag, which defines the hashtag, and which gives the hashtag also a certain type. So vehicle speed would have here the type signal. And we require that every hashtag used is declared at some other place such that it's 100% defined what is meant with that hashtag. If you're doing that, then you can actually use that hashtag for navigation. So you see already it looks like a hyperlink that can take you to the declaration. And with the declaration, you can provide much more information to that hashtag. That sounds pretty simple. And it is also simple to use because the formalism behind it is something that people already know from social media. Everybody knows how to use hashtags. The language is actually a bit more complicated. It provides multiple types. So for example, hashtags could be of the type signal and operation or objects. We can also use it for declaring parameters or features. There are also user definable types. It provides also advanced features like namespaces and scoping, which look then a little more difficult. But what we actually try to avoid is to make the language too complicated. We don't want to use it to write pseudocode. We actually don't include on purpose any logical or numerical expressions. We can't perform calculations with that language because we want to avoid that people start writing pseudocode. They shall just write requirements in a very simple and still intuitive language. So even if the language has some extended features, the very basics of the language just consists of the hashtags which have references where they are used and declarations which declare how the hashtag looks like. And that's something easy to understand for everybody, essentially. If you're using that, you can very easily use the language used in the requirements for automatic analysis. So for example, very simple analysis will show you whether every hashtag that you're using here actually has a declaration. So for example, in the requirements, you can quickly see that the tag traffic sign recognition has not been declared somewhere else, which actually means that your requirements are not yet complete. So a certain amount of completeness can be shown with these requirements. You can also make simple analysis like, okay, how many of these unresolved hashtags do you have? Or even advanced analysis, which tells you, for example, that some hashtags are used more frequently in relation to others, like vehicle speed seems to be very frequently used together with wheel speed or something like this. So these are quite simple types of analysis, but how does that help us, for example, to promote the right abstraction level of requirements? Well, what the hashtags do is actually, or what they actually act as placeholders. So in the requirements text, you could use the tag vehicle speed, which at the moment is kind of a placeholder. And for example, doesn't tell you which interface in the software or which variable in the software actually represents the vehicle speed. You don't know how to measure that variable. But that information can be provided later. So once you start defining things like play alarm sound, for example, which at that step of requirements engineering was defined here, you can later go and define more details for that play alarm sound, or you could provide more details for the vehicle speed. So essentially, these variables, these tags, serve as placeholders and therefore give the reader of the requirement the guarantee that the information that is needed to understand vehicle speed or play alarm sound may be added later. But that gives you the opportunity, for example, to approve that requirement, including the placeholders today, because the placeholders give you the guarantee that at a later step of development, in a design step, for example, more information will be added. So you can approve the requirement now, even though the information is missing, and add the information later. The most interesting analysis, however, come when you go one step deeper, when you don't restrict what you're doing to pure requirements, because no one says that these hashtags are restricted to writing requirements. They can actually be used throughout the whole development tool chain. So we are already using it one level deeper in the software architecture. And we, for example, implement such tags in our software architecture diagrams. And then you can suddenly see the power of that language, because if you have a requirement which says the signal vehicle speed is the estimated wheel speed, and you assign this to a class called vehicle speed estimator, then essentially you know that that vehicle speed estimator somehow must produce this signal. If you have another requirement, our example requirement, that when the vehicle speed exceeds the speed limit recognized by the traffic sign recognition and so on, then do something, then you know that this requirement somehow consumes the wheel speed as an input. This requirement needs the wheel speed, while this requirement somehow provides the wheel speed. And if the providing requirement is associated to one class in the software architecture, and if the consuming requirement is associated to another class in the software architecture, then actually you can derive already that there needs to be some kind of interface in the software architecture between the consuming class and the providing class, because the consuming class implements a requirement which needs access to a variable which has been defined in another class. So to some degree, you can already do kind of a consistency check between your software architecture and your requirements. Your requirements, by using these hashtags, already implement kind of a signal flow of these signals, of the vehicle speed signal, for example. And once you start allocating this requirement in your software architecture to components, you already have a very basic flow of information between the components, which you can cross-check against the interfaces that you later on define in the software architecture. So you may now ask, is this actually replacing the typical traceability that we have? So typically we use traceability to say a certain requirement is allocated or satisfied by a certain software component in the architecture or by a software design. Does the hashtags replace that traceability? So if we go and place hashtags indoors for requirements and in Rhapsody for the architecture and in some other documents, maybe even be Word documents or MATLAB Simulink models for the design, wouldn't that replace the traceability that I typically usually need to have between these documents? We are clearly saying no, we do not want to replace the traceability that we have already in these documents. Instead, we are placing additional tags in the documents which form their own layer of traceability, and that additional layer of, we call it lightweight traceability, actually allows us a certain amount of consistency check between these various artifacts. So this additional layer of lightweight traceability, where we don't have to do the traces actually ourselves, they are implicit because we use the same hashtags, that allows us a certain consistency and correctness checks of the various artifacts that we have there. So it's an additional layer of information which gives us very good analyzability for functional safety purposes, for example. So how do we implement that actually in practice? We have chosen to go for a tool called Yakindu Traceability by a company called Itemis. This is a standard traceability measurement tool which can interact with a lot of other tools in the typical automotive development environments. It connects to Doors, it connects to Rhapsody, I believe also Enterprise Architect for sure, MATLAB Simulink, and a range of other tools. And from there it can extract traceability data to do metrics, for example, or easier navigation between all of these artifacts. We've teamed up with them to implement a plug-in to that tool. And within that tool, we have actually implemented parsers to read the requirements and parse out the parameters. There are query, we can now show all the hashtags used. We can show problems associated with these hashtags, such that some hashtags, for example, are declared twice with the same name, or that there are name collisions in the namespaces or some things like this. The tool is very flexible, such that we can implement a lot of user-defined queries, which help us to validate for a lot of other rules, and thereby we have a good tool support to do all of this consistency tracking. If we would want to develop a little bit further and ask what could we do with that approach actually, one great thing would be if this simplified usage that we achieve by using the hashtag approach could actually extend to an even more intuitive, even better tool support. We have a very lightweight formalism here, which invites users to write requirements in a very easy way. It's very easy because we can build on their previous knowledge, and we can make the whole approach also generally therefore very intuitive. But it would even be better if it would be much deeper embedded in the tools. For example, if you could imagine that we would have could have an editor which, while typing like a code editor, sees that you start typing a hashtag and could already come up with a proposal engine. While you're typing, you type only #SPE, and it proposes you existing hashtags like speed limit, speed limiter, speed assist, or whatever. Like you know it from coding, if you would have something like that for requirements, which also while typing already tells you, well, this hashtag is actually not existing, there is a validation error, that would be a great extension. We couldn't achieve that level of comfort until now in our environment, but that would be definitely a great step to move forward. Also, other directions into which we are thinking is actually integrating the whole approach with tagging requirements, integrating that with natural language processing such that we have at least kind of an auto-tagging mechanism, which helps us to use artificial intelligence to analyze our requirements. So the approach that I told you of today is used already in hundreds, maybe a 4-digit number of requirements already in the braking software development system. We are starting to use it actually also to release our requirements, because this consistency checks give you an amount of requirements quality checking. And I believe this is definitely a good approach to spread requirements over, well, in the end, hundreds of people whose day job is mostly to write software or develop systems, but not necessarily always to write requirements. Use an easy language that they know already, and it will be much easier for them to write requirements. Thank you, ladies and gentlemen, for listening to my presentation about requirements engineering made easy. I hope you've enjoyed that talk, and I'm looking forward to your questions, which you can enter in the box on the right side of your screen. Just please give us a few seconds until we switch over to the Q&A session. Thank you.